We're going to now talk about the concept of heat and internal energy. First of all, when we talk about friction, if you remember, we said force of friction is a non-conservative force, it's a dissipative force. And what it does is it converts mechanical energy to internal energy of the system. It causes heating of the system. The temperature of the system increases. So let's define precisely what is internal energy. So internal energy of a system is basically a measure of the total energy. It corresponds to the sum of energy terms from rotations, vibrations, and translations. So rotational kinetic energy, vibrational energy, translational energy, etc. of all atoms and molecules that make up the system when viewed from the center of mass reference frame. So remember, we have to measure the motion from a reference frame, and in this case the internal energy is defined with respect to the center of mass reference frame. So it's the total energy of the system. It includes contributions from mechanical energy components of atoms and molecules that make up the system. Now, it's basically, when you say that the internal energy of the system is so many joules, you're basically stating a state of the system. On the other hand, the concept of heat is basically describing the transfer of energy across a boundary. Heat is the transfer of energy across the boundary of a system. And when does this occur? Due to a temperature difference. So when you make a thermal contact between two systems and there is a temperature difference, delta T, we will find that heat must flow, energy must be transferred from the hot system to the cold system. Therefore, finally, we will have the equal internal energy on both sides, equal temperature on both sides, and there will be thermal equilibrium. So it's very important that heat is the transfer of energy and internal energy is the energy of the system. So we can hear some statements about these terms, internal energy and heat and electromagnetic radiation, as well as work. For example, you might hear that one says the boiling water has a lot of heat. Heat is not something a system has, it's the amount of energy transferred across the boundary of the system. Therefore, the correct version of this is the boiling water has a lot of internal energy. So we need to correct this statement. It was very hot that day because the sidewalk was radiating lots of heat. Heat is not radiated, electromagnetic radiation is emitted. So we have two ways of transferring energy between two systems, heat and electromagnetic radiation, due to a temperature difference. And therefore we cannot say the sidewalk was radiating lots of heat. We can say the sidewalk was emitting electromagnetic radiation. The sidewalk was too hot, the temperature was too high, therefore it was emitting lots of electromagnetic radiation. Another incorrect statement has to do with work. The work of the system A was 100 joules. Now, heat and work are two similar concepts in the sense that they both describe the transfer of an energy into and out of a system. So we cannot say the work of the system was 100 joules. Basically, we can say the work done by the system A was 100 joules. So the system A is doing work on the environment or on another system, and the total work done by system A was 100 joules. Okay, so just to summarize, basically in thermodynamics we have two types of variables, energy variables, transfer and state variables, and heat and work are so-called transfer variables because they describe the transfer of energy to and out of a system. And on the other hand, internal energy is basically describing a state of the system. It's the total energy associated with rotations, vibrations, and translations of the atoms and molecules when viewed from center of mass reference frame. It's a state variable. We're going to come back to this concept later on when we talk about more about engines. Okay, so how do we measure heat? So we need to talk about unit of heat. Heat is measured in units of calories, and 1 calorie, and you have to pay attention to the first letter, it has to be lowercase. 1 calorie, it's abbreviated as cal. 1 calorie is the amount of energy that is necessary to raise the temperature of 1 gram of water from 14.5 to 15.5 degrees C under atmospheric pressure. Now, as you have seen here, heat and work are both transfer variables, so they're both describing the transfer of energy into and out of a system. And Joule has shown that there is a mechanical equivalent of heat. So here is Joule's experiment. We have a paddle that turns as these two blocks fall down, and we see that as the paddle turns, because there will be friction between the paddles and the water, the temperature of the water rises, and this whole system is thermally insulated. So we just have energy transfer between the paddle and the water, and we see that the mechanical work done by the two blocks of mass as they fall down is transformed into heat in the water, and therefore it's going to start heating up the water. And so we find that using Joule's experiment, there is a mechanical equivalent of heat. The mechanical equivalent of heat, because they're both describing transfer of energy, is basically found by Joule to be 1 calorie is equal to 4.186 joules. So we can describe the energy transfer, mechanical energy transfer, 4.186 joules. It's equivalent to heating the system by using 1 calorie of energy transfer. Now I would like to take a look at an example in order to clarify this concept further. A student eats a dinner rated at 2000 calories. Now I would like you to pay attention to the unit here, calories. And this C here is capital C. All right. He wishes to do an equivalent amount of work in the gymnasium by lifting a 50 kilogram barbell. How many times must he raise the barbell to expand this much energy? Assume he raises the barbell 2 meters each time he lifts it, and he regains no energy when he lowers the barbell. Okay, so the total energy we would like to expand is 2000 capital C calories. This is equivalent to 2000 kilocalories. All right, so this is an important remark here. There is a difference between food calories and calories. So 1 food calorie is shown with the capital C. 1 food calorie is equivalent to 1 kilocalorie or 1000 calorie. So capital C is reserved for food calories. Now we find that we want to expand 2000 calories. We have a 50 kilogram barbell, and the height that we are lifting it to is 2 meters. So every time he lifts, he's going to expand some energy. The work done will be equal to mgh, and this is going to be 50 kilograms times 9.8 meters per second square times 2, that is 980 joules. That is mechanical work. Now, according to Joule's experiment, 1 calorie is equal to 4.186 joules. So I have 980 joules of work equivalent to 980 divided by 4.186, 234.11 calories. Now the total amount of energy we have to spend is 2000 kilocalories, so it's 2 times 10 to 6 calories, and he can do this by raising the barbell every time. So let's call n the total number of times he raises the barbell. Every time he raises the barbell, he spends an energy 234.11 calories. So we find that n is equal to 2 times 10 to 6 divided by 234.11. So n is equal to 8.54 10 to 3. So he has to raise the barbell 8,540 times in order to spend this much energy, and therefore the dinner he eats is completely expanded by using this exercise in the gymnasium.